Bless the Maker and his water. Bless the coming and going of him. May his passage cleanse the world and keep the world for his people.
These last few weeks I've been dealing with a situation at work where plain text credentials were being stored in a certain configuration. So we were trying to see if there are mitigations that we could implement to lower the risk of those credentials being in plain text. And just going through that exercise made me remind of this other news that I saw a couple of weeks ago about this worm that was trying to steal secrets from local development environments. So I thought of doing a video on this, kind of cover the whole situation to see if there are certain things that we could do to minimize the risk. And the more I read about this worm, the more it becomes clear that just a single developer restricting their access to the cloud is not going to do. The more it becomes clearer that this situation could be one of the worst incidents of your development career. So instead of a comprehensive guide, let's talk about Shai-hulud, the old man of the desert. Shai-hulud is a malware that behaves like a worm. Basically, it steals credentials that are available in that local environment. It could be a developer laptop, it could be a pipeline, and it also multiplies into other trusted packages if there is access from the location that it has already infected. So this is not a typical supply chain attack where you would be safe if you just stick to the trusted packages. In this situation, even the trusted packages could be a source of malware injection. Despite its behavior, I really like its name. Dune is one of my favorite sci-fi novels of all time, and I'm even going through the unpopular prequels and sequels. But unfortunately, the name is the only redeeming quality about this situation. Everything else is really scary in my opinion. So let's get to the whiteboard and let me go through some of the details first, because it's important to discuss how this worm behaves before we can discuss how we can mitigate the actual risks. So this supply chain attack basically targets the NPM ecosystem. So it has gone for the maximum impact. In fact, JavaScript is one of the most popular languages in use, and majority of the software developers actually work on JavaScript stacks, so it makes sense to target that environment. And also this is a language that gets used both on the front end and the back end, so if you do actually get into a certain environment, there's a chance that that environment could actually be a backend. So it makes sense to target attacks into a popular language unless you're targeting a specific setup. It looks like it has been active for only a couple of days, but within those days it has managed to infect over 200 packages. I see some numbers that put it around 180 packages, but the scary thing is that most of the packages that have been infected, most of the packages that have acted as carriers for this worm have been trusted packages. So for an example, this might not be a surprise at this moment, but some of the packages that have been published by CrowdStrike itself have been carriers of this worm. Basically what this worm does is to steal credentials, see if it has access to other NPM packages that it could replicate itself into, and also try to leak private data that are in GitHub private repositories. It's really interesting how this worm behaves. If you just go into how that happens, basically there's a post-install script in an infected package that executes the actual worm, the script that contains the worm. The post-install command runs after the package is installed. So if you run npm install, this script is run immediately after the package is installed in the target environment. And what it does is to go through a series of steps that tries to steal credentials and try to expose those credentials in multiple ways. So one of the first things it does is to try and see if there are GitHub credentials in your local environment. And in my opinion, this is a good bet because most developer laptops will have some kind of GitHub tokens that the developers will be using to, pull and push commits. So it will be looking for both older and newer versions of GitHub personal access tokens, and usually these would be stored in some kind of key ring or credentials manager, but there could be tokens in environment variables as well. So if it does find GitHub credentials, then it will try to iterate over the repositories that the credential will have access to and see if it can inject GitHub workflow action that could read secrets from that repository. In my opinion, this is what makes it really scary, because pipeline secrets like GitHub secrets, they are usually treated as a source of secure storage. But in this case, depending on the level of access the token has, it is able to extract those details by just running a malicious version of a GitHub workflow. So if it does find those details, it tries to send those details over to another third-party website called webhook.site. This site is not really operated by these attackers. It looks like just a general third-party developer tool that is mostly used to test webhook invocations. But the interesting thing is I run a Pi-hole ad blocker at home in my home network, and this site seems to be in the list of malicious websites that I depend on. So if you have some protection like this, you might be able to get around this issue, but let's discuss that possibility later. One thing it does is to extract details like this through a remote endpoint. Also, it tries to see if there are private repositories that this credential has access to. If there are private repositories, it will copy those contents from the private repository, and I think that includes the Git history as well. So it copies the entire Git store, and it publishes a new public repository with a suffix called migration. So anything that you would have in a private repo would be exposed as a public repository. The next thing it would do is to see if there are NPM tokens in the local development environment. So these tokens could be in something like the npm-rc file. If there are tokens, then it tries to see if that token could list any packages that the owner would be maintaining. And if there are packages, then this would be the vector that it will try to replicate itself. It will publish a new version of that package with the injected malware. So this is why even the trusted libraries and packages seem to be sources of infection, because if you manage to infect one upstream library, then it's possible that you'd be able to infect a lot of other trusted packages, because if that package is upstream enough, then chances are most developers would be using that package in their development environment. Another set of secrets that it will try to look up are the cloud credentials. So credentials like AWS, GCP and Azure credentials. It will try to see if there are credentials in local files, environment variables, and even I think it tries to see if it can access the instance metadata service. And additionally, it looks like it uses this tool called TruffleHook, which is a tool that I personally use to see if I'm going to push credentials accidentally. But in this case, some variants of this worm tries to use TruffleHook as a way to find existing credentials. So I guess TruffleHook doesn't leak secrets, people do. But in any case, after collecting all of those details, it will try to publish these details, usually double base64 encoded, and it tries to publish those details into a public repository called Shai-hulud in the GitHub profile, and this data seems to be usually in a JSON format called data.json. Initial reports seem to say that this worm only affects Linux and macOS environments, but some reports that I've seen actually have screenshots of this data.json, which seems to have parts that are Windows specific. So this might not be the case. This might be targeting Windows environments as well, and it kind of does make sense because a lot of developers either have macOS or Windows laptops. The chances of having a Linux environment for a developer is really slim, especially in most corporate environments. So I would think anyone who would write something like this would be targeting any environment that it could get its hands on. So with that, if we take a step back and try to understand what this does, what we basically see here is a life cycle of the worm. So in Dune context, that's going to be a sand trout that grows into a sandworm and ultimately ends up being the old man of the desert. But in our case, this is a lot more scarier than getting, I guess, eaten by a sandworm, because this situation can be a really carrier limiting move. The first entry for us is probably from a trusted package, trusted npm package that could end up in a local development environment, and as soon as that package is installed, it will try to look up secrets, it will try to leak GitHub secrets, and it will try to also expose GitHub private repositories. So what can we do to kind of mitigate this situation? There are multiple things that would act together, but I don't think a single a security control could actually stop this from happening. So the first thing we could do is to scan dependencies. So this is a well-established security practice. But on the other hand, if you are a developer, you would probably be trying out new libraries. You'd probably be writing code that needs new libraries. So this isn't really possible if you don't use something like a proxy that sits between the upstream npm repository and your development console. So again, established corporate environments could actually have that, but if you're a startup, you're a small scale organization, this luxury is not really there. So you might end up in a situation in the future where you have a really destructive worm like this, a really destructive malware that runs on your developer laptop. So if that actually happens, what can we do to mitigate our secrets from getting leaked? First thing we could do is to limit the access we have into the cloud. So one of the key things that I keep repeating in almost every video is that you should probably not have administrator access into production. So if you are a developer and if you have administrator access into production, that's a really bad place to be. Least privilege principle, role-based access control, everything helps to reduce the attack vector here, or the better terminology there is probably blast radius. But anyway, if you have the minimal permission that you need for the cloud environment, the amount of damage that could be done at this point could be really limiting. Another case is you could also be using short-term credentials. So for example, if you use IAM Identity Center in AWS, you could be using short-term credentials. So the use of IAM users to access cloud resources should be really minimized. There are other situations where you could use cloud-specific controls to reduce the blast radius of this action. Well, when it comes to GitHub secrets, this is something really interesting. Now the malware goes after personal access tokens, and it is really easy to have a personal access token that has broad access to everything in your GitHub profile. I used to do this myself personally. I used to generate personal access tokens, especially the older kind that had access to everything, because it was just easier for things like pushing and pulling commits. I would just have a token that could do everything. On a positive side, I haven't done that maybe in 5-10 years, but it's really frustrating to keep generating short-term personal access tokens if you need to work on multiple repositories. GitHub actually has several controls for this. You could have personal access tokens that expire frequently. You could have tokens that are scoped to a specific repository, and you could even restrict it down so that it could do only certain actions. So if you're using a token to pull and push commits, you could just limit the token usage to those actions to a given repository. But on the other hand, most repositories would have workflows that get triggered on commits being pushed, and usually you don't really restrict commits into master branch. So the way this malware behaves is that it will try to inject a malicious workflow into the repository itself. So even if you scope down your personal access token, you can't really stop your repository secrets from getting leaked. So this is a really frustrating situation, because even if you do the best you can when it comes to generating personal access tokens, you can't really get around what this malware does. When it comes to securing information through making repositories private, I think there have been enough examples in the past that shows making a repository private is not really a security control. GitHub has shown in the past that you can't expect a private repository to be private in its entire lifetime. For example, if a private repository gets forked and the fork gets made public, then the private information would actually be public. So there are various examples like this. So even before this malware, there were plenty of examples to show that making a repository private is not enough to keep information secure. So if you're pushing sensitive details into a repository, always make sure to encrypt them with a key that is not in the same repository, that has separate strong access controls, so that even if your repository gets made public, your sensitive data would still be secure. Another thing that I already discussed was scoping the personal access token to only the actions that you need. So for an example, you can scope your personal access token to not be able to create new repositories, not be able to change certain details about your control plane in GitHub. So if that happens, even if the personal access token is exposed, then there's a chance that the malware would not be able to publish that detail into a public repository. But it also depends on how the malware behaves. Certain variants of this malware could be using other ways of exfiltrating data. So let's talk about data extraction. I've seen two ways this malware tries to extract data out of the system that it has already infected. One way is try to use this webhook.site endpoint to extract data directly into another location. But if you have strong network protections like network activity monitoring, or monitoring to see if there are malicious DNS lookups going on in your network, then you might be safe from this way of data extraction. But on the other hand, most startups don't have this level of network security, so this can be a really dangerous point. Running a Pi-hole instance like I do at home could be really helpful in this kind of situation. So even if you're a small scale operation, you could actually do that. Get a minimal network setup going on with some kind of network monitoring that could actually block a lot of malicious requests from going out. The other method that it tries to use is to publish data into a public GitHub repository, and it comes down to the previous point I made about restricting the level of access your personal access token has. This is a really scary scenario, so one thing you could probably do here is to depend on third-party security notices, but as a single developer, there's nothing you could probably do other than trying to restrict the scope for the tokens that you generate. So after extracting all of those details, it will try to replicate itself into new NPM packages if the environment it has access to publishes new packages. So an obvious answer here could be to not publish packages from your local environment directly into a registry, and only to do that from a pipeline execution, for example through GitHub. But that kind of becomes invalid because the malware will probably have access to that GitHub pipeline as well. There's no effective way you could balance developer experience and security in this specific case, because if you are a package maintainer, you might probably have a token that has access to the repository itself. Then the malware would be able to inject itself into the pipeline, execute, so a signed and verified version of the package would be published. The mitigations you could have here are really limited. You could have multi-factor authentication, you could have manual approvals that hold a publishing pipeline from actually executing, but then again that option is only available in certain GitHub tiers, and most package maintainers would not have that GitHub tier to begin with. So this is probably why within the couple of days this malware was active. It was able to infect close to 200 npm packages, and most of them trusted packages. So in my opinion, this is a really scary situation to be in. So that's a brief breakdown of Shai-hulud, the old man of the desert. It looks like this is the second kind of attack of this nature. There has been another kind of self-replicating malware that has tried to attack the NPM ecosystem just recently, and I think this won't be the last time. In this case, there's no single action that you can take to mitigate the risk entirely. There's a list of things that you can do that would mitigate the risk to a certain level together, but at the end of the day, I think what's really effective is to keep an eye out, keep scanning your dependencies, and try to act as soon as possible when you get notices like this. I'm pretty sure this is going to happen again in the future. The name might be different, but the same kind of attack, the same kind of design would be used again, and it might be useful to keep an eye out for signals that show that you have been compromised. I'm personally more paranoid than I was yesterday after reading the design. I don't have any advice that would prevent this from happening in the future. I don't know, hide your wife, hide your kids. Having said that, that's it for me. Thank you so much for watching. I'll see you in the next video. Of other ways of exfiltrating data. That's hard.